produces uh, changes in it, and a carbocation formation takes place over here. Now Br minus can come over here, so we have this formation. In place of Br minus, if we have OH minus, Cn minus, or say uh, nitrite, we can have this all. So in a way, we are using all these anion to trap this C plus. Similarly, we can trap free radicals, and here we see that nitroso compounds are being trapped, are being utilized to trapping of a free radical by a nitroso compound. So we are using, so this is a free radical and we are using nitroso compound and activated alkene. So this, say like in this example, uh, we are using mercuric product. So we all know uh, this formation taking place because this will be like this. So this become minus, this plus, and this is Ag2 plus. So one of the, so this breaks into HgOAc plus, and then the OAc minus comes out. So OAc minus shall go over there, and this one, uh, so this is minus, and yeah, so this is minus, so HOAgC shall come over here, and this thing OAC shall come over here. So this goes like this. So this wants, this thing is telling that we can even, so we know that when this thing leaves, HGOAC leaves, we have a free radical formation taking place over here, yeah, and this can be trapped by CH2CH kind of a thing. So these are the things that are employed for trapping of the free radicals. Similarly, for the carbenes, uh, we want to trap the carbenes. We all know that this Riemann-Thimann reaction, a carbene formation takes place because we have a base, um, and say like this, and we all know that CHCl3 eventually comes to this point, carbene formation taking place. This is a E plus system, and it shall come over here. So how do we know that this formation uh, takes place? So we can employ this thing if this carbene formation is taking place. So we all know that if we have something like this, and we have a CCl carbene kind of a system, so we can have this thing. So we can even trap carbenes in case of Riemann-Thimann reaction, um, this one, and that tells that we have a formation of carbene. Similarly, how do we know that nitrines are being formed as intermediates? We can trap in a similar fashion. Not only that, we can even trap benzene. So we have a benzene, and we have a um, anthracene, and this Diels-Alder reaction formation taking place over here, and uh, which is manifested in this way. Say like we have a furan, so this act as a diene kind of a system, and this one as a dienophile, and we can have this thing. So benzene, so this clearly tells that the benzene formation takes place and the trapping takes place over there. A little bit about intermediates versus transition state, nothing more to say about it because we all know that this is a reaction coordinate, so we will have a transition state. So this thing CCl, this has to be broken, so this starts breaking up, and so we have this delta minus, this delta plus, so this is a transition state, and we get an intermediate when finally this gets broken off, and then we have a product. So what are the important things? Well, an intermediate is a short-lived unstable um, short-lived unstable molecule, whereas transition state uh, is just as the state before formation of a new molecule, involves breaking of bonds and the formation. An intermediate differs from a transition state in that intermediate has a discrete lifetime. It does have a lifetime, say of a nanoseconds or even many days, as we saw that we can trap them. But the transition state lasts for just one bond vibration cycle, which is femtoseconds. So intermediates may be unstable molecule, in which case they are called reactive intermediate or highly stable molecules. The difference between them can be better described through the energy profile diagram. Uh, Also, the transition states are local energy maximum and have a partial bonds. This might be one of the reasons why they can't be isolated as intermediates. Next, we have to talk about crossover experiments. We shall be talking about them very soon.